Hey guys, so yesterday we talked about the roots of a quadratic equation, or the zeros. Remember, they both means the same thing, of a quadratic equation, and how if I give you a graph, you can determine what those roots are. So today you're going to be basically doing pretty much the same thing, but then you're also going to be asked that if I give you the roots, you have to be able to tell me whether the roots I've given you are the correct roots for that equation or not. So for example, this says, can 5 and negative 1 be the roots of x squared minus 4x minus 5? Now, one thing that you can do is you can use the graph of the equation. If you can sketch it, graph it if you have graph paper, whatever you can do, and see where does your graph cross the x-axis. Because remember, the roots are also your x-intercepts. Okay, where does your graph cross the x-axis? So if I have x squared, if I have this equation here, x squared minus 4x minus 5 is equal to 0, as long as my equation is equal to 0. So again, equation has to be equal to 0. As long as my equation is equal to 0, okay, I can replace the 0 with a y and just put that into y equals. So I'm going to put in y equals, I'm going to put in x squared minus 4x minus 5, and I'm going to go ahead and look at the graph for that equation. And when you graph it, it looks something like what I have on my screen. Once I have the graph, I want to check, okay, if this is my graph, where does my graph cross the x-axis that I have right here? We don't care about the y-axis, we don't care about any other crossing, we care about where does your graph cross the x-axis. And I can see that there's a point right here, which is the point negative 1 comma 0, and I can see that there's a point right over here, which is the point 5 comma 0, which means that my roots are the x values are these points. So we have x is equal to negative 1 and x is equal to 5, which then shows me that what the question is asking is true. It says, can 5 and negative 1 be the roots of this equation? And by looking at the graph, I can definitely prove that they are. Another way that you can do this is you can also look at the table. So if the roots they're giving you are whole numbers, okay, this only works if the roots that they've given you to prove, like 5 and negative 1, are integers, then you can use your table to do so. So you can put y equals x squared minus 4x minus 5 into your calculator, and because you're looking for your zeros, you're looking for your roots, you're looking to see, if you notice that all the y values for our roots are always going to be 0, so you're looking to see for what points on your table are your y values equal to 0. So if I put this in y equals, and I go to my table, I'm going to scroll up and down the calculator in my table till I find the zeros in my y's. And you're going to see, be careful, okay? Now there's zeros on your x, you want zeros on your y, you want zeros on this side. And if you look at your table, you're going to see that you have the points again, negative 1, 0, and 5, 0. So the roots of your equation, once again, are the values negative 1 and 5. And again, that's just another way of writing it. I can write it like this, or I can write it this way. Both of those things mean the same exact thing. The other way that we can do this is that if these are my solutions to my equation here, if these are the solution to this equation that I have over here, then that means that if I plug in negative 1 for x, or I plug in 5 for x into this equation, then what should it give me? If you said 0, that's correct. So I'm gonna prove, first I'm gonna prove that negative 1 works. So I have x squared minus 4x minus 5 is equal to 0. And I'm gonna prove that when I plug in negative 1 into my equation, everywhere I see an x, it has to give me 0. So I have negative 1 squared minus 4 times negative 1 minus 5. And I'm looking to see, does that equal 0? I'm putting a little question mark because I'm not sure. I have to put it in my calculator. But when I put this into the calculator, I'm going to see that I do get 0. Okay, so that means it works because of course 0 is equal to 0. Now I'm going to go ahead and try my other point. Now I'm going to try, because I have to prove that both of them are roots, not just one of them. Just because one of them works doesn't mean that the other one works as well. So now I have x is equal to 5. So again, I have my equation, x squared minus 4x minus 5 equals 0. And now I'm going to go ahead and plug it in. So I have 5 squared minus 4 times 5 minus 5 equals 0 with a little question mark because I don't know if that's true. But when I put this into the calculator, I can see that, again, I get 0. So that means that both of my points work. So there are 3 ways that you can do these problems. One, you can do the graph. You can look at the table, only if it's whole numbers, only if they're integers. Okay? Or 3, you can plug in. Okay? Any of those 3 strategies would work as long as you're showing your work or explaining how you find your answer. On this second example, I have 2x minus 3 and x plus 7 is equal to 0. Just because the equation looks different doesn't mean that we're still not doing the same thing. If I were to multiply these things out, I would get 2x squared. Sorry, if I were to multiply these things out, I would still get x squared as my biggest exponent, which means I'm still doing the same thing. I'm still dealing with a quadratic equation here. So I'm trying to figure out which of these are the solutions to my equation. So again, you can use any of the strategies that I gave you in example 1. You can either do the graph, okay? You can do the table, but remember that it only works for whole numbers, and I see some fractions here, so the table might not work for all of these options. Or you can plug in. So I'm going to try the first option. The first option is telling me that negative 7 and 1.5 are my solutions. Remember that this is not a point. This is not the point negative 7, 1.5. That's not what that is. Okay, this is a solution set. This is telling me that my solutions to this equation, or my roots, or my zeros, they all mean the same thing, are x is equal to negative 7 and x is equal to 1.5. Okay, so I'm going to go ahead and plug in for this one because I can't use the table since this is a fraction, so it's not going to show up on my table. So I'm going to go ahead and plug in. First, I'm going to prove is x equal to 7 a solution. So I'm going to take my equation, 2x minus 3, x plus 7, and I'm going to plug it in. So I have 2, parentheses 7 minus 3, parentheses 7 plus 7, and I'm going to prove whether that's the solution or not. Okay, I don't know if that's true. I have to figure out what this is going to give me first. Then I'm going to go ahead and check whether 1.5 is a solution. So I would have 2, parentheses 1.5, minus 3, parentheses 1.5, plus 7. And again, I'm checking to see, does that give me 0? When I put this in the calculator, does that give me 0? So I'm only going to set it up for you guys. Your job is to finish up this problem after you've watched this video, and when you submit your task, you must submit example number 2 and the whole mini lesson completed for us to check as well. So this is going to be the part of your task. You're going to finish this, and then you're going to start your task. I want to see whether you guys can do this on your own first, and then go on and do the rest of the problems.